Welcome, everyone. This is Carl Ford. I am your moderator for Generating Business Insight and Advantage from IoT Data. This is going to be a very interactive conversation with Splunk and ThingWorx giving us great insight. I want to remind everybody that we are going to save questions to the end, but feel free to place them in the queue anytime you want. And 24 hours from now, this recording will be available, and we have 3 poll questions this time, so it'll be very interactive. And I got to commend the team for doing what they've been doing. And the team consists of Brian Gilmore, who's Senior Manager and Solutions Expert for IoT and Industrial Data from Splunk. Brian, let everybody hear your wonderful voice.
Hey, glad to be here, Carl. Thanks for having us.
Okay, and Jack Reeder, who's the Business Development Manager, ThingWorx, a PTC business. So, Jack, say hi.
Thanks, Carl. Thanks for everyone being here.
Yep, we really appreciate it. Like I said, this is going to be very interactive, and we're going to start with Brian. So, Brian, I'm going to advance the slide to the front page, and you take over from here.
Sure. Well, just wanted to give a quick background on Splunk for some of the audience who may not be familiar with us. Splunk is guided by our mission, which is to make machine data accessible, usable, and valuable to everyone. And I'll cover a little bit later in the presentation sort of what our definition is of machine data and how it affects most enterprises. But I think that's really our guiding principle, and that's something to keep in mind as sort of I go through the rest of the presentation. A little background on Splunk as a company. So we were founded in 2004 really by some of the guys who ran data centers for some of the largest organizations in the world. And they were largely disturbed by the fact that they had much more access to data on the internet than they did to data in their own data centers. And this was data being produced by applications and servers and networks. And so they set out to build a product that would make, as I said, machine data accessible, usable, and valuable to everyone. Shipped software starting in 2006, grown quite quickly. We have global headquarters here in San Francisco. That's where I'm based. And then we have other regional headquarters in London and Hong Kong. Over 1,400 employees worldwide. We are publicly traded on the NASDAQ stock market. And we have several products. We are a multi-product company. The product we're most famous for probably is Splunk Enterprise, which can be deployed on-premise or in your own cloud. But we also have Splunk Cloud, which is a software as a service model of Splunk. Hunk, which is Splunk Analytics for HDFS, NoSQL data stores such as Cassandra and MongoDB. Splunk Mint, which is a set of SDKs and data pipelines to deliver data from end-user mobile applications to the cloud for Splunk Analytics. And then a whole suite of premium apps, which cover use cases like enterprise security, PCI compliance, and things like that. We're really proud of our customers. I mean, they're some of the most creative customers on the planet, over 9,000 of them now in over 100 countries worldwide. 75% of the Fortune 100. And Splunk's a horizontally scalable platform, so we have customers, paid customers who are running everything on their laptop, customers that have scaled up to massive scale, indexing, analyzing, and getting real-time value out of over 400 terabytes of machine data per day. So with that, I'm going to pass it back over to Jack. He's going to tell you a little bit about PTC and ThingWorx.
Thanks, Brian. Really appreciate the opportunity to be here with everybody today. And Brian, it's been great working with you and the On24 production team here. And thanks to Carl for moderating. Let's talk for a moment just about Parametric Technology Corporation, better known as PTC. And then I'm going to just quickly go over ThingWorx. PTC was founded in 1985. And its mission in life continues to be to transform how products are created and serviced in the physical world. Everything from motorcycles to parts for cars and parts for tractors and complete bills of material and all of the software and systems that are needed to design and develop individual components, starting with CAD software, and now completing an entire portfolio of software that represents product lifecycle management. In size, we're approaching $1.5 billion in revenue. Our primary focus continues to be industrial products, and we're going to be talking about how that relates as a point of view on the Internet of Things today. 28,000 active customers, so, and a very active set of customers who give us feedback all the time. And maybe most importantly, in 2013 and 2014, PTC has made two big bet acquisitions on ThingWorx and Exeda Corporation to complete this idea of a closed loop of not only designing products and placing those products in the physical world, but creating a feedback loop now that products have gotten smarter and are more connected. In November of this last year, in the Harvard Business Review, an article was published by our CEO, Jim Heppelman, together with Dr. Michael Porter from the Harvard Business School, called How Smart Connected Things or Connected Products Are Transforming Competition. And a lot of the concepts that I'm going to be talking about today, which complement Brian's point of view on operational intelligence, come from this article, and I would encourage everyone here to get a copy of that HBR article. So ThingWorx, real quickly, is a set of tools that do three things: reduce the complexity of data collection and connectivity, since that's what we're talking about with the Internet of Things and how things become more connected and more real-time. Modeling, which is the basic theme for how we understand the interaction of things with applications in the physical world. And then software or middleware that allows companies to manage and scale those things in the physical world as if they were just another IT asset. So that's ThingWorx. I think what I'll do now is turn it back over to Brian, who's going to kind of get us in a little deeper in a good way with operational intelligence.
Thanks, Jack. So, advance the slide here, sorry. So, one of the biggest challenges out of getting value from data, especially around the IoT, is piecing together all of the parts for data collection all the way through analysis and prediction. And we'll go into a little bit more depth around this subject here. But one thing to keep in mind when you're working with platforms like ThingWorx and with Splunk is that sort of the end-to-end solution is really valuable in terms of both time to value and ability to do, extensible solutions and integrations. Splunk does go all the way from data collection through analyzing and predicting that data. And when we talk about data collection, where we're a little bit different from, say, a platform like ThingWorx, is that we don't always have some type of data collector that would run directly on the device out in the field. We collect data at a little bit higher level in the architecture. So collecting data from ThingWorx is quite powerful and quite valuable for customers. Once that data is collected, we pull it into an index. So it's really important to understand about Splunk is that we're essentially a data recorder. There's no underlying relational database technology. The data gets indexed in its raw format, and any schema or any sort of field extraction or anything that needs to be done is applied at search time, which makes it incredibly flexible. And at search time is important because Splunk's analytics sort of paradigm is all based around search, much like what you would do in Google, where you you search for data either based on just characters or key value pairs. You drill down to the data that's valuable to you for whatever sort of troubleshooting process you're doing, whatever analytics process you're doing, and then you can go through, run analytics on the data, and actually get to the point where you may have found some insight that you want to alert on. And alerts in Splunk, of course, can be sent to emails. They can do things like trigger scripts, and they can actually do things like connect up to work order and ticketing systems. So you can be looking at lots and lots of data and actually doing something with that data automatically and in the background. Of course, we have a very powerful reporting and visualization platform. A lot of that is based on capabilities to enrich data in Splunk, both with external data sources like relational databases, as well as what concept that we have called a lookup, which allows you to build CSV files that sort of may have some key that is in your raw, unstructured, or other machine data, and you can pull in additional metadata fields from those CSV files or from relational databases, or even from HDFS or NoSQL if you so choose. And finally, we have a suite of analytics tools built into Splunk, so you can actually go ahead and run statistical processing on those queries and your searches. You can also extend Splunk with Python, and we also have an app that allows you to pull in the R statistical processing language, so that anything you can do in R, you can do directly from the Splunk interface. Like I mentioned before, we scale from laptop to data center. Largest customers are using over 400 or indexing over 400 terabytes of data a day. Out of the box, our data storage tier is highly available and allows for disaster recovery, which is great. No need to sort of configure that with complicated, piecemeal solutions. It's all configured right through the web interface. We do have full admin capabilities built into the platform as well, so you can have users, you can map users to LDAP roles or to custom Splunk roles. I also mentioned that we have an apps framework that allow customers to build top-end solutions on top of Splunk. We already have over 600 of those posted to apps.splunk.com. And we have a full suite of SDKs and APIs, and I think that's really important when you're looking at integrating a system like ThingWorx and Splunk. Because what those SDKs and APIs, sort of on both sides, ThingWorx's SDKs and APIs are really powerful as well, have allowed is that you can build an environment with Splunk and with ThingWorx where through the Splunk interface you have access to a lot of what you can do in ThingWorx, and through the ThingWorx interface you then have access to a lot of what you can do in Splunk. And what that allows is sort of as a partnered platform, and we're very happy to have ThingWorx as a sort of strategic IoT platforms partner. It allows the people who are comfortable and familiar with working in the ThingWorx environment to be able to harness the power of Splunk through ThingWorx. And on the other hand, for the people who are comfortable in the Splunk environment, they're able to harness the power of ThingWorx through the Splunk interface. And I think that's a really key integration that's not really there out of the box for many other platforms. To get started in Splunk, and we don't really have the benefit of doing a demo here of the platforms, either in combination or independently. So just would definitely recommend if you're interested in learning a little bit more about Splunk, you can go online to Splunk.com, click the free Splunk button, and you can gain access to either our free online sandbox, which will spin you up an instance in Amazon Web Services. You can go right ahead and connect it up to your ThingWorx instance. There is a free download for on-premise, which you could also connect up to your ThingWorx environment and test out some of the concepts that Jack and I are going to be discussing here. And then, of course, we also have Amazon Machine Images. So if you already have an Amazon Web Services account and you want to go through and just spin up Splunk in your Amazon Web Services, you can just do a search for Splunk, and there's fully supported AMIs right there available to you from your Amazon Web Services console. So what does Splunk do? Well, Splunk is a platform for machine data. We like to sort of think of machine data as is really the largest component of big data, because big data comes from machines. We have a sort of specific but broad definition of machine data. It should be human readable. Again, I mentioned that search is sort of the paradigm of analytics or for analytics in Splunk. So if humans are typing the search queries, the data being in human-readable format is, of course, very important. It should be time-stamped, because a lot of what you can do in Splunk is based on windows in time, looking for sort of averages or statistics over 15-minute periods or real-time from 30 minutes ago until now. So in fact, if you're sending data to Splunk and it doesn't come with a timestamp that was sort of applied to it at collection time, Splunk will actually assign a timestamp to it, just so it has sort of the right place in that recording. That you can snapshot in relational database tables there, objects and things like that from the ThingWorx environment, and it's a very powerful platform. But there's a whole bunch of sort of machine data sources that are valuable to pump into a system like Splunk. This is data from like GPSs, RFIDs, hypervisor systems if you're running your ThingWorx or other environments in a virtualized environment, web server information, etc. So, the data that comes out of ThingWorx is a really powerful machine data source for analysis in
Mm-hmm. Mm-hmm.
So we have a concept of, how you can go through, and starting with just the raw machine data, how can you can really move to business insight and business advantage. And I'm going to sort of focus this in on the IoT relevant data. Splunk is well known, of course, for our ability to analyze IT data and business data, but looking specifically at the IoT data. It really is sort of a maturity model, right? This is a process that you need to go through. One of the very first things you do with the data is you start to collect it. And people often ask, well, what do you collect? Splunk really does allow you to collect it all. And that may seem a little bit inefficient to begin with, but you really don't know what questions you're going to want to ask tomorrow or next week or next year. So to start building sort of a broader historical record will really set you up for success in terms of this operational intelligence process. And once you have all this data sort of available in a system where you can look through and start to search and, maybe, support some of your intuition and things like that, you can really start with that search and investigate process. So this is going to be just sitting down at the data, having domain experts in particular processes looking at the data, just saying, I have a feeling that this process isn't going well, or this particular object or device isn't working correctly, not to its specification, not to how it was programmed, not to how it was engineered. And if you can sort of quickly search through the data and identify the pieces of information that are required to sort of define whether or not it's following the expected processes, that's a really good first step. What happens as the second step is once you never really want to ask the same question twice, or at least not the same question 3 times. So once you start asking some of the same questions over and over again, it's really important to have a system where you can take those searches that you sort of ran on an ad hoc basis, using those ad hoc correlations and things like that you've done, and set them into sort of real-time alerting and monitoring processes in the background. And there's approaches to do that both in Splunk and in ThingWorx, and together it's a really powerful approach. Once you move past that, you can start looking at operational visibility, which is really taking everything you've learned from those first 2 steps and turning them into key performance indicators. No longer worrying about the specific pressures or temperatures or speeds, but looking at global things like health scores, risk scores, and things like that. And once you get to there and you've modeled all your data up, which Jack is going to cover in detail, to that level, you really can get a high-level view. What becomes really powerful, especially in a platform like Splunk, is you can drill down from those KPIs to the raw underlying data if you've saved it and you have that granularity. So when you see a health score that's declining or a risk score that's increasing, a natural next step is going to be to want to actually go drill down through that KPI and figure out what's causing it. Is it a particular object or device? Is it a particular process, etc.? And then finally, you take all 3 of those and you sort of put them together into an environment where you can really start to model what business outcomes are being affected by sort of all of those previous steps. So how might a KPI and a health score for your manufacturing process or for your oil rigs be able to define for a business analyst how your supply chain is going to run over the next month, or what your revenue might be the next quarter? And I think those are really the questions that you want to be able to answer. Jack, do you have any thoughts on that?
No, I mean, that's what we talked about getting ready for the call. It's what I like about, I think it is a maturity curve. I think what we've talked about and, is a common between Splunk and ThingWorx, I'll call it a business approach for how to help customers no matter where you are, no matter where the customer is, no matter where the end user is, or no matter where the product is in its maturity. So it's not one size fits all. If customers don't know what they don't know, and this Internet of Things paradigm shift is still sort of a mystery, you need tools to start to ask the right questions. It's not even about getting the right answers. It's, what questions do I need to ask about a pump on an oil platform, or what's the relationship between a pump and a drill rig, or a drill rig and the weather? The fun part about the Internet of Things is this, this endless set of questions. And so what Splunk and ThingWorx, I think, help along the way, and it's, wherever you are, it's fine, is we start with this ability to search and an ability to model. And I think to me, that's really the power, Brian, what we're trying to communicate here today is what happens when what if you had tools that allowed you to model the physical world at a product level, at a systems level, or at a complete, operations level, and it's an and, right? And you could search along the way and ask questions in real time. I just think that's new, right? We weren't able to do that just a few years ago even. So
yep.
To me, that's the take on this slide is you could really be at the beginning point of just trying to figure out what questions to ask. You could be, and you need modeling and search. You could be at the proactive monitoring stage where, frankly, a lot of the physical world is already monitored and controlled. I mean, the Internet of Things isn't providing anything new in that sense from a programmable logic controller perspective. So, but what is new is this, this intelligence and embedded technology that says you need to now search differently and you need to model differently. And so that's where you're starting on the curve.
Awesome.
And I think between Splunk and ThingWorx, we've pretty much got it covered no matter where you're at.
Yeah, great. So we're going to hit a poll question really quickly, and then I'm going to actually go through a couple of real-world customer success stories in the Internet of Things around each one of these stages. But first thing I'm going to do is just pass it back to Carl for a quick poll question.
And here it is, folks. The poll question we're asking is, when it comes to machine data, what types of data do you think would bring the most value for your company? Is it user behavior? Is it cybersecurity? Is it application behavior? Is it service levels? Is it customer experience? Or is it something else? And as I was listening to you, Brian and Jack, talking about this, it occurred to me how old I am. I used to manage a billing system in the carrier, and we had to adhere to EBCDIC formats because of the fact that our whole system was kind of designed to not worry about how much traffic we were passing through, because of the fact that at that point transmission was expensive. So all the information was incredibly small, and you just tried to minimize it as much as we can. Today, with memory being cheap, with the internet being available, the world's so much different in terms of what you can manage and threshold. So I'm very curious as to what the audience sees, So any thoughts about, how that changed? Jack, you were kind of alluding to that earlier.
Well, I mean, I think the title today has to do with business insight and advantage, and that's relative. So, I mean, we only had what we had in 1975 or in 1995 in terms of tools to provide insight. A lot of the technology was, batch-oriented. It was, frankly, traditional IT-oriented types of tools to provide insight and advantage, and companies did, right? Companies, suppliers provided, and made a lot of money on software that, ERP software, et cetera, that provided a lot of insight in terms of business intelligence and even some level of operational intelligence in the physical world with industrial software and control sequences. Closed loop. But we're in a whole new era now, right? This is the point for me, Carl, and I'll toss it to Brian here, but I mean the point for me about the Internet of Things is that it's just so much easier now to create insight. I mean, you don't need to be, have a master's degree in computer engineering to create insight anymore. I mean, we're all doing it in our houses. You type in search routines. And to Brian's point, being able to automate that, it just transforms the interaction between people and people and people and things. And the next 5 years it's going to be interesting to see how business models are affected by all this. also. I don't know, Brian.
Yeah, I completely agree. I think for me, one of the single most important changes that the Internet of Things has really enabled is the capability to move from an ETL, like an extract, transform, load type intelligence or analytics process to a streaming real time. Because, either way, if the devices were batching data to relational databases and because of like sort of that ETL process, the data really wasn't available to the business until the next day or the end of the week or after some batch process had happened. The insights were suitable to that sort of architecture. Now that we can literally get data from the sensor to the CEO in just a matter of milliseconds or seconds, you really have to think about how that can sort of change the overall business processes. I mean, it's always available, always up, always real-time information for key decision makers. I have a couple slides there I'd love to cover on sort of how customers have sort of achieved some of this, and then I can pass it back to you. Do you want to move on off the poll results?
Yeah, I think the poll results, the people have seen them. What's clear is that people are definitely looking for stuff from the Internet of Things that has to do with user behavior. So I think this whole thing about customer experience, application behavior, and user behavior, basically representing almost 80% of the feedback, kind of shows exactly the fact that people are really looking for how the business performs overall from this. So go ahead and take it away.
Excellent. Thanks. So tell you a quick story about a company. So we have a partner who's actually implemented a solution at POSCO, who's the fourth largest steel manufacturer in the world. And what they've done, which is really interesting, is they have synced together live real-time streaming data from sensors, live real-time streaming screen captures from all of the HMIs, and live streaming video from the closed-captioned TVs. This is sort of the type of application that you could very easily create with a combined Splunk and ThingWorx. And the power of this is your searches are no longer restricted to the numerics and the Booleans and the multi-states. It actually allows you to say, like, okay, well, we noticed, say, at POSCO, a furnace temperature spike at 2:30 p.m. Like, let's rewind everything to 5 minutes before that and play back the videos and play back the screen captures from the HMIs and see if did somebody just make a set point change? Was somebody in the room shoveling, fuel into the furnace? Or was there actually some issue that caused that, that spike, like the furnace flared or something like that? And that's all about having these sort of diverse data sources that you can search and investigate to put whatever the incident you're looking at into context. Another of our customers is doing a really interesting sort of proactive monitoring and alerting, where a lot of times you think of proactive monitoring and alerting as just identifying problems. But what Royal Flying Doctor Service has done is they've used proactive monitoring and alerting to present opportunities. So they use Splunk to analyze data from the engines on the airplanes, from the GPS locations on the planes, from sensors that are in the refrigerators. And they're able to sort of mash that all up together and sort of build themselves like an FCC type environment where they know where the planes are and what's going on. But because they actually are able to track the location of the planes, they built a program called By the Sky, which is a lot like Adopt a Highway, where they built geometries of the sky, in the sky over Australia, virtually of course. And they have proactive monitoring searches that watch planes, and as they pass through these geometries, the system connects up to Salesforce and sends an email to everybody who sponsored that patch of sky, thanking them for their support and letting them know how many life-saving flights have traveled through that patch of sky, which I think is just an incredible reuse and repurposing of the underlying data that was really probably gathered for operations and troubleshooting perspective. In Royal Flying Doctor Service, the third largest air carrier in Australia, but solely delivering doctors and medicines to patients in hard-to-reach rural areas. We've got a partner who also has built a platform for the U.S. Air Force where they're actually analyzing data from multiple generations of automation and control systems. They're indexing in data from power meters. And with a system like ThingWorx and Splunk, what you're able to do is give the end user sort of a single pane of glass and a single point of truth into all of these sort of diverse data sources. Which means that nobody has their own version of the truth. I mean, a lot of M2M over the past decade, at least the part I was involved in before I worked for Splunk, was really P2P. So you had somebody going into their system, extracting and formatting data, dumping it to a CSV, putting it on like a jump drive, and taking it to somebody else who's loading it into their system, maybe having to do some reformatting to get it into their environment. And you had sort of all these versions of the data that sort of rolled up, and maybe eventually they made it into some joint system where there was actually, some correlations that could be made across the data. But there was not a lot of, collaboration around the data and things like that. As you're thinking about building out these sort of comprehensive IoT and business analytics platforms, you really want to think of it as like a campfire, where employees from the engineering division, employees from the CEO office, the COO office, the CIO office, the marketing team, everybody can use that data to the entire business's benefit. And I think that's just a really powerful paradigm to be able to introduce to an organization. I think probably one of the strongest examples of outcomes we have, which is really a real-time business insight stage, is with New York Air Brake. So New York Air Brake indexes, analyzes data from the control systems on the locomotives. They gather data from the back offices of the railroads, and they're presenting a service to the Class A railways, freight railways, where they're actually making recommendations for how drivers should drive the trains for particular segments of rail. And they've built these algorithms they call the Golden Run, which basically it's loaded into a sort of heads-up display in the cab with the driver, and at certain points it tells them to apply acceleration or apply brake on certain cars or whatever. They're also tracking the driver's compliance with that. The reason is that when the driver's compliant, they're seeing 5 to 8% savings in fuels per segment. And they've calculated that they saved their customers in 1 year over $1 billion in fuel and wear and tear on the trains. And that's really going back to what we were talking about, which that's enabled by streaming real-time data analytics. With a lot of ETL, those types of insights are really, really difficult to get to. And I just want to sort of present you with an option for how you can really get to this streaming real-time business insight from IoT data. And I think this really sort of lays out an architecture for how ThingWorx and Splunk will work together to sort of to present or provide a platform for this. Stage one is the analog, right? So this is the continuous stream of analog electrical signals coming off the sensors. There's a ton of value there. We're really not to the place yet where we can do full-scale digital recordings of every analog signal that's coming off. So there is some digital sampling that's occurring. And this is really where we have to think of the device. So you've got things like meters that are sort of abstracting devices. And this plays a lot into what Jack is talking about with modeling, controllers and networks. Once those devices are presenting data to things like log files and databases and models, you want to be able to make sure that you can run your insight layer on those data sources in real time with processes like search and easy analysis, pivot, things like that. And then, of course, once you get to those insights, you really want to make sure that you can make those insights available to everybody. And through a powerful sharing platform that you can do through components of the ThingWorx platform and components of the Splunk platform. So with that, I'm going to pass it back to Carl for another poll question.
Excellent. And we're asking the question, what stage do you believe your organization is in when it comes to turning machine data into operational intelligence? Are you at the search and investigate stage? Are you at the proactive monitoring and alerting? Do you have operational visibility? Or do you have real-time business insight? And I want to just give everybody a few seconds. I got to say, you guys have done a great job of making these slides complimentary. And when Jack takes over after this, I think it's going to all come together nicely. So with that said, I will push out to the audience what the results are. And guess what? We've got a whole bunch of youngins in this world here who are at the very beginning. So we've got a great opportunity here. As the statement goes, there are no shoes on this island. Great opportunity. Let's bring some more here. So go ahead and take over, Jack.
Thanks, Carl. Ryan, before I go to my slides, I just want to reinforce what you were saying about real-time and streaming. I'm not sure. I mean, we've got some pretty technical folks on the call here. When I look across the audience and just how technically, how sophisticated some of our audience members are here today, Brian. But people need to realize that, traditionally data lived in databases or in files, relational database management systems. And now, as Brian was saying, this idea of streaming, looking at the data as it's flying in, high velocity, high volume, and high variety, different types of data from different types of machines located all over the planet, never even reaches a database. It's viewed and the insight and the intelligence is created in memory. I just find that amazing. Don't you, Brian? I mean, it's just,
Yeah,
it doesn't say the databases are outmoded. Of course, we still need large data stores for high volume and historical analysis, but to be able to look at data as it's flying in memory, I mean, oh my God, right?
Yeah, I mean, real-time streaming has to be a component of any sort of modern IoT analytics platform. It's just got to be there.
Yeah. So again, I think so. I'll advance the slides here. So the question is, for me, trying to help our customers with Splunk, what does insight mean? What do we mean by that? And again, as we're saying, it could mean search and investigate. I think, Brian, your framework, your business approach of, from analog to insight and, from search and investigate through to, real operational intelligence, it's a process. You made that point earlier. That's clearly our perspective at ThingWorx. It's a process. Customers and and the Internet of Things community is not going to wake up tomorrow and just have world-class operational intelligence of all Internet-based or non-Internet-based things communicating with each other in the machine-to-machine idea. That's a great vision, but it's a process. And I think it's important to model along the way. What do we expect? That's really what we're here, I think, to help guide together Splunk and ThingWorx. What should our customers expect if we were to model an oil well or model an airplane or model the weather or model in this picture here, a product, a tractor or a truck, and the properties related to that product, the oil pressure, the temperature of the engine, the speed of the tractor, how do we model an ability to do that in real time? I think we all know how to take the data, put it in a database, and then, a week later or a month later, look at, okay, how did the tractor do last week, or this time last season in spring, or all the snow we're having, in Boston. I mean, is that something we should be modeling, right? All the changes in weather and weather patterns. I don't know, but it brings up this whole question of baselining and creating a stateful view of how products are operating in the physical world and the interactions between humans and those products, the operators, all the services personnel, et cetera. And so there is this logical or natural progression of how to achieve operational intelligence over time. And if you see at the bottom of this slide, the idea of data transparency. It's not a new term, transparency, but I think in when we start to add the real-time component, transparency brings on a new meaning. And so I would ask everyone in the audience here to really think hard about when we say search and investigate, and we did the poll here. What does transparency mean from a search and investigate perspective? What are the sensor readings that we should be having or we should be getting from a machine, from an asset, from a device in the physical world on a regular basis directly without having to go through a control-based infrastructure? Is there a way to get that data natively up into the cloud and in a place where we can combine it and recombine it with other kinds of data? That is all just monitoring, right? Then there's the whole question of control, which is, all right, great, now we know in more real time how to monitor the behavior of machines. What about the control piece? Controllers aren't going away. We need control for the physical worlds, but how do we change the control sequences at the product level, what are called PID loops, and the whole idea of a feedback loop so that we improve the operational intelligence of control? How do we model control, right? And that's the idea of ThingWorx as a set of tools. After we take out the complexity of collecting the data, the question is, how do we model these different behaviors? Monitoring, control, eventually optimization, and then ultimately autonomous self-sufficiency. The Harvard Business Review article talks about these stages that all companies are finding themselves going through with the Internet of Things. And again, the importance of search from Splunk plus modeling from ThingWorx. Along the way, you're going to need those capabilities, and they really become, if you will, competencies that we think enterprises are going to need to adopt in and of themselves outside of traditional IT competencies. At the end of the day, if you look in the lower right of this slide, it is about investments. It is about risk. It is about defining new types of interactions between machines and other machines, machines and humans, and of course, people to people in new ways, new types of relationships, new types of interactions between service personnel and end users and their customers, etc. So there is this progression. It's not one or the other. It's this aggregating up of monitoring and control plus it's all and control and optimization, and autonomy. And what you need along the way is a common set of tools to make sure you can get there. That's what we're trying to say here. That is operational intelligence. Operational intelligence becomes this journey, and you have to be able to handle different types of data to get through the journey, whether those are structured types of data or unstructured types of data, and at different types of velocities to achieve different types of insights, which could be strategic insights, operational insights, or traditional product level, machine level insights that are really event driven. This is really just to say there are different, as Brian was saying, different types of use cases. It's a good model, I think, to understand how to model the physical world, whether it's structured or unstructured, or what level of velocity and volume of data you're throwing at the problem. Those are considerations that need to be applied as you're using tools to model the physical world. So I'll skip over this. These are really just use case examples. I think Brian did a good job covering use case examples. And so really, in summary, we think there are 4 stages, just as Brian described 4 stages for how to approach the Internet of Things. Starts with modeling. From modeling, once you help determine devices that are becoming good IoT citizens, you then start looking at smart systems, which unveil new applications and revenue streams. Stage 3 is about changing the balance from CapEx to OpEx of the products themselves, since the value is now in the data more than it is in the product itself over the life of that product. And then ultimately, how to change value chains for whatever industry you're in. I think our audience probably understands this. And again, the point is to have a set of tools along the way that allow you to move from modeling to managing to transformation and ultimately operational intelligence and business insight. There's challenges. There's always challenges. The products that were designed 15 or 20 years ago don't support real-time data search and investigation today, which is what Brian was saying. I like to talk about this in terms of what I call minimum viable intelligence, which is sort of combining the idea of minimum viable product, which some of you may know, with the idea of operational intelligence. And it turns out that you don't need to make all products incredibly smart everywhere all the time in real time. There's this idea of minimally viable. And the question is, how do you model the idea, this idea of minimum viable intelligence along the way? I think that's pretty much what I wanted to say. Brian, let me just toss it over to you. Any comments on what I'm trying to present here in terms of different stages of adoption of operational intelligence from modeling to transformation?
No, I mean, I think that it's important to understand that when you're looking at sort of your model of maturity in Splunk, or the model of operational intelligence that we sort of described, there's parts of those models that are sort of dependent on the others, and then there's parts that can sort of develop independently. So, I think as people start to, connect platforms like Splunk and ThingWorx to operations, processes, people, and devices, you may mature more so in the, the data connectivity and the modeling and the operational side of things in ThingWorx, but, it's important to have all of that data available from within Splunk so you can start to, when you need to really sort of optimize those processes and things like that, you'd have the capability to do that, and you could start sort of moving from level 1 to level 2.
Mm-hmm.
So it's time for me to ask.
I was going to ask Brian a quick question, Carl.
The question is, what challenges are you finding in your modeling? Is your IoT modeling need issues? Do you have issues with legacy software and products? Unpredictable variety, volume, velocity, and visualization? Requirements for new modeling paradigms? Outdated and inflexible business models, or other? So I know for myself, this world has become very iterative, so I wouldn't be surprised if we have a wide range of answers here as a result of this. And let's see what our audience is telling us. Requirements for new modeling paradigms. Okay. With that said, Jack, bring us home.
Well, I thought what we needed, what Brian and what we talked about is we need a slide that describes, I think, synergistically an overall framework for how to address modeling, search, and analytics. Brian, do you want to describe your view on this?
Yeah, I mean, I think it's just important to know that it's collaboration. So, I mean, there's certain data that's really efficient delivered directly to Splunk. There's other data that's, definitely efficient to deliver directly to ThingWorx. But by Splunk having full access to sort of the full power of the ThingWorx environment through APIs and SDKs and vice versa, you can really have these conjoined environments where, for the processes and things that are being managed and monitored in ThingWorx and the processes and applications that are being managed and monitored in Splunk, it's not a one or the other thing. I think the integration that ThingWorx has done with Splunk is incredibly impressive. They've literally gone through and taken our SDKs and our APIs and wrapped them in their own composer environment. So from ThingWorx, you can dispatch data to Splunk for storage. You can query data. You have full access to the full complement of Splunk analytics. Any data that's on the Splunk index from even IT data sources or data sources that would never pass directly through ThingWorx. And you get that true combined environment of all of the different models, objects, data, etc., that will really let you understand the global view of your operations.
Mm-hmm. Yeah, and I think what we're saying is, you need all of that along the journey to operational intelligence, right? Whether you're in the investigate stage, you're in the monitoring stage, you're in the optimization or autonomous stage or the insight stage, right, as Splunk talks about. You need an infrastructure and environment that allows you to continually ask questions and get, new truth, new data of record back in more real time, I think, like you said, Brian.
Yep.
So you guys want me to push the slide to the next one? So is this interactive on the summary here?
Yeah, I'll go ahead.
No, I was going to say, I think we just covered a lot of this.
Okay.
I think it's an iterative process. It's a collaboration between two powerful platforms, and I think it opens a lot of opportunity for people who are trying to gain business value from the IoT.
Okay, that's great, because I've got a tremendous amount of questions that people have been sending here. So I'm going to...
You can't optimize
this, and let me get to the...
You can't optimize what you can't model, Carl. That's my moral of the story.
Sounds right. So the first question is value created from connection or smarts, diagnostics, pronostics, and autonomics? How's that for a deep question?
The answer is yes. Next question. All of it. Depends where you are, right? If you haven't, there's a logical progression here. You got to take care of the connectivity and the complexity of data collection, as Brian was saying, regardless of the type of data, and apply good hygiene there, right? This requires somewhat of a disciplined approach. You can't just, machine by machine, connect it up, get insight, go to the next machine. If you take more of a systems approach, I think you got a shot at scaling, an IoT infrastructure. That's what I would say.
Yeah, I agree.
Okay, so the next question is, what is the learning curve for going from modeling to transformation in months?
Interesting. Wow. Now that's go.
I think I think months, is maybe not the appropriate. So I think it depends. I think you've got two tools or two platforms where there's a very fast time to value in terms of doing something with both Splunk and ThingWorx. And with the right people, with the right domain expertise in terms of how things should be working, I think clearly, you could be getting time to value within days or less.
Hours.
If you already,
hours.
If you have an existing environment where you've already connected, you've done the hard work of sort of integrating the devices, getting the data and delivering it to Splunk and asking questions either in ThingWorx or in Splunk is you'd be doing it right away.
Okay.
Yeah, hours.
So how about the real-time collaboration on the data in context to issues and recording the interaction, resolution, and costing of any issue in the ThingWorx platform?
Yep, and so that's the real, and those are the last question plus this question is the idea of the larger closed loop, Carl. This is the idea, which is, okay, great, I can figure out what's happening, what's the state of a machine, to then do root cause analysis and figure out what do I do differently, how do I change my business processes. That's the real insight and work that's required, and knowledge of how it should be working and why you need to model intelligence. Not so simple. That's a little more human-based at this point, I would say. Anybody can feed data, to create intelligence, which is why search tools are needed.
Okay. Is real-time decision support about big data, small data, or something else?
I think it's about context. Yeah, I think so I think it's about context. So the primary data, maybe the one piece of information that you're focused on is small data, right? A single table of time series information from a pressure sensor will tell you if that pressure sensor is spiked over time. The big data component is the context. Why has it spiked over time? Is there some repeating piece of metadata or piece of information from some other system that can help you figure out or model when that spike has occurred and then predict it or prevent it in the future?
Okay. I aim this one at you, Brian. It says, we often talk about differences between operations perspective on data and that of the IT department. How are you seeing your systems being used by each group?
I think it's very common or similar. So the sort of three main use cases we could group most of our existing adoption of Splunk in the IT world into are operations and troubleshooting, number one. Number two is cybersecurity, safety, and compliance. And number three is business analytics, like taking the data that you've gathered from troubleshooting or cybersecurity perspective, putting it in front of a business analyst, and having them figure out how that's going to help model the business. Those are exactly what people want to do in the IoT as well. They're just a little bit different data sources, a little bit different form factor in terms of the compute. But the processes and the troubleshooting and the processes and the securing of the networks and the devices and the people who are involved with it, I think the same tools can apply very, very well.
Okay. It says here, how are you defining operational intelligence, and how are you defining analytics?
That's a really good question. I think to not be sort of maybe indescriptive, but operational intelligence is more of a state of mind, or it's a process. It's a constant iterative analytics mindset where you're interacting with the data, you're tuning, you're going through, you can run analytics that just constantly run in the background, but you're never going to reach operational intelligence until you tune those analytics. You look at how the output of those analytics relate to each other, etc.
Mm-hmm.
Jack?
Yeah, and I would add the word adapting. I think it's continually adapting to changes in the physical and virtual world. If you can do that, you're creating operational intelligence. It's that adaptation.
Yeah. Well said.
Okay. Next question is, intelligence as a result of the type of analytics that are applied. Is this included, or do the customers of your products need to develop their specific analytic models and algorithms to pull the intelligence out of the raw data?
Mm-hmm. So, we do have a partner program, and we do rely on very smart data scientists and very smart partners who are specialized in specific vertical industry use cases and applications to help our customers really create the insights together with Splunk, of course. But customers are expected to come, understanding their own processes and their own systems, and that's what we hope in the modeling exercise.
Okay. Most companies are startups in the IoT space. What is the cost barrier to entry?
Depends on what level of IoT you're defining. If we're just talking about, again, a dispensing machine or a tractor or using a Raspberry Pi or an Arduino board to connect up some physical thing and have data flow into some program, and that is the Internet of Things, then yes, the barriers are very low. If we're talking about system level, mission critical applications on which customers are running their core businesses around the world, and the role that machine data plays in the interaction with customer relationships on a daily or real-time basis, it's a very high barrier to entry.
Yeah, the only thing I would ask there is, or I would sort of add there is that, I think we should stop looking at these projects as having a cost, and we should really focus on the return. I think just to do the IoT for sake of doing the IoT is probably not the best business plan. But if you have some known benefit that you can get, from doing the types of initiatives that we've been discussing, you should be able to monitor and look at your return. Like, how are you more efficient? How are you having fewer devices break, how are you better, operating so that your supply chain and your revenue streams are more beneficial to the business? It's not really it shouldn't be a cost-based decision. It should be based on what you will get out of the project.
And I think the point I would leave the audience with is transformational, right? Which is, at the end of the day, the Internet of Things is really a lever or a catalyst for business transformation. And to Brian's point, if you're only focused on costs, you're missing the disruption, and you're missing the opportunity to really create new revenue streams and new relationships with your customers and social network. So I think transformation is the longer term view on this.
Yeah, well put.
And I think with that said, I think that was the great concluding comment. So we've got lots of other questions here that some of them I would love to get answered, but I'll tell you what, we'll do a Q&A together, and we'll go from there. Please, thank you, audience. Remember that this is available 24 hours from now, and I want to thank you, Brian, and you, Jack, for all your efforts, and also the entire team. It's been a great collaborative effort.
Yeah, thanks so much, and thanks to everybody for attending.
Thanks, Brian.